Hello, and welcome to 5 Minute Math. Today we are looking at 2D and 3D shapes. This is 3.6a Readiness Practice, the advanced version. If you are interested in exploring the intermediate or proficient versions for 3.6a, or for looking at the Readiness Practice resources aligned with any other standard, you can find them by using the link in the video description. So we've got two sets of groups here, and Sari has sorted them, and we need to do several things. We need to name each solid. We need to describe two similarities between group 1 and two similarities between group 2, and then provide a shape that could fit into group 1 and a different shape that can fit into group 2. So we need to provide a rationale for each shape. All right, so let's start with naming each solid. So these are all prisms. So let's just go ahead and just put that over here. So prisms are three-dimensional solids that have two polygon bases, and they are connected by rectangles. So this is a rectangular prism, this first shape. And I am going to kind of show you the two polygon bases. So my bases here are this rectangle and this rectangle, though for this rectangular prism, you really could choose any of the two opposite faces, and those could be your bases, and that would work. So this is a cube. It's a special type of prism, special type of rectangular prism, in which all the faces are squares. So I'm just going to choose top and bottom, but you could choose any of the pairs of faces. Now this one is a triangular prism, this third one, and this third shape, the triangular prism, is not actually sitting on its bases. So you can have bases even if they're not sitting on it. So the two triangles are the two polygon faces, and those are the bases, but it's sitting on one of its lateral faces or its sides, and that's fine. All right, so down here, if we want to know what type of prism this is, let's just count the sides. 1, 2, 3, 4, 5, 6. And so that is going to be let's do this other one. 1, 2, 3, 4, 5, 6. So six-sided shape is a hexagon. So this is a hexagonal, thick hexagon prism. And then this shape here, 1, 2, 3, 4, 5. You probably recognize that as a pentagon. 1, 2, 3, 4, 5. So that is a pentagonal or a pentagon prism. So pentagonal prism. So we've named all of our shapes there. And what do we need to do next? Well, we need to describe similarities that we are going to see between the shapes in group 1 and then the shapes in group 2. So two similarities. Well, we've started looking at faces, so I want to finish with the faces. So let's look at group 1. If we count the faces, we got 1, and then we've got 2 bases, correct? And then what we have are we've got 4 faces that connect those two bases. And we know it's 4 bases because each base is a quadrilateral. It's a rectangle specifically. And so there are 4 sides, so 4 extra faces connecting the two bases. So 2 bases plus the 4 connecting bases, because it's a 4-sided base. So I can say this has got 6 faces. Same thing with this cube, right? I've got 4 sides on each base, right? So I've got 2 bases and then 4 connecting faces connecting the 2 bases. 4 plus 2 make 6. So this also has 6 faces. They're just all squares. Now, this has got 2 bases, right? The 2 triangular bases. And then it's got 1, 2, 3 connecting faces because each base is a triangle. It's a 3-sided shape. So my 2 bases plus my 3 connecting faces and you have 5 faces. So one thing we could say about group, let's say group 1, is you can say they each have 5 or 6 faces. Doesn't have to be exact. You just want to kind of give a range. So that could work. What else could we say about group 1? Well, I've actually outlined the edges. So what I've outlined in blue are my edges here, right? And so these are my edges, and I've got 1, 2, 3, 4 on the top, 5, 6, 7, 8 on the bottom, 9, 10, 11, 12. So I'm just going to kind of write this right here. I've got 12 edges, and I've got the same thing for my cube. 4 on the top, 4 on the bottom, and then 4 connecting. 4, 4, 4 make 12. So I can describe this as 12 edges. With my triangular prism, I've got 3 on one base, 3 on the other base, and then 3 connecting. Are you noticing that pattern, right? You're going to have the same number of connecting edges as you are the number of sides in your base. So 3, 3, 3 make 9 edges. So I can say I've got 9 or 12 edges. And let's just look at one final thing. If you wanted to, you could have described the vertices. 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8. They're corners, but the technical term is a vertex. So when we describe more than one, we call them vertices. I've got 8 here. So I can say 8 vertices. Now, you'll find the pattern when we look at a triangular prism. 1, 2, 3, 4, 5, 6. We just take the number of sides on the base and double it, one for each base, and you're going to get your total number of vertices, 6 vertices. All right, so we can say 6 or 8 vertices. Now, what can we do for group 2? Well, let's also describe them for our faces and our edges and our vertices. Okay, so we got 1, 2, 3, 4, 5, 6 sides there, right? We've got 6 sides there. And so guess what? We're going to have 6 rectangles connecting our 2 bases, one for each side. So when I've got 2 bases and then 6 connecting sides, 2 and 6 make 8. So 8 faces. And look at my pentagon. I've got 2 bases, and then I'm just going to connect my 1, 2, 3, 4, 5 connecting rectangles because there's one for each side of the base. So I've got 2 bases, 5 connecting rectangles, and so that makes 7 faces. And let's put that right here. I'm going to change that because I'm going to need that for my next part when I need to draw an extra shape. So I'm going to put 7 faces right there. So we can describe group 2 as either 7 or 8 faces. And I've also actually just written, or I've traced over my edges. So how many edges do I have? Well, I've got 6, right, on each base, 6 and 6, and then I've got 6 connecting, 6, 6, and 6, 3 sets of 6s. So that's going to get me 18 edges. And look at my edges on my pentagonal prism. 5 on the one base, 5 on the other base. That's another 5 and 5. And then I've got a third set of 5 connecting the 2 bases. So that's going to give me 15 edges. So I can write 15 or 18 edges. That's what's going to fit in group 2. And then let's do the same thing with my vertices. 1, 2, 3, 4, 5, 6. Remember, you just take your number of sides on your base and you double it. So 12 vertices. So I'm going to find 10 on here. 1, 2, 3, 4, 5 on the top. 1, 2, 3, 4, 5 on the bottom. And I will say 10 vertices. So they follow patterns when you're looking at prisms. They're different when we're looking at cones or we're looking at pyramids. They don't necessarily follow these same patterns, but when we have prisms, they definitely follow these patterns. So I've got 10 or 12 vertices. Now, I want to name a different shape that could fit into group 1 and a different shape that can fit into group 2, provide a rationale for each shape. All right, so I want to draw a triangular prism here, and I want to make it look very different. So that's one triangular prism. I'm going to draw a triangular prism, or at least I'm going to try to. That looks almost like a block of cheese. I want to get it to where it's sitting on its base. So sometimes you'll get a triangular prism, and it'll kind of look like this. All right, so let's see if we can make that connect here. And so when you're looking at it like this, let's see, we'll see this is solid. It'll kind of look like this. So this is a triangular prism, but you notice it has the same set of faces, vertices, and edges as my other triangular prism. This is just what it looks like when it's actually sitting on its base. So let's see if we can notice all of our shapes. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we've got 9 edges, and we've got vertices. 1, 2, 3, 4, 5, 6. It's got the 2 sets. So I could describe it with the same language, right? I can say 6 vertices. I can say 9 edges. And how many faces does it have? Well, it's going to have 5 faces. 5 faces. Because it's got the 2 triangles that are its bases, and then it's got the 3 rectangles connecting those two. All right, so that's just one new shape that you can draw, and really that's not a new shape, it's the same shape, but I just wanted to turn it on its base. Now, if I wanted to draw a different shape here, let me see if I could draw an octagonal prism. Now, if I draw an octagonal prism, it's not necessarily going to fit my, it's not going to necessarily fit my description, so I'm going to need to change my description, right? So let me see if I can make it a little bit better. And you know what, honestly, I'm going to do what this hexagonal prism did. I'm going to see if I can draw it on its side. Like that. And so if I were to just draw a whole bunch of lines back like this, right? A whole bunch of dotted lines like this, and then we would need to get a octagonal prism like this. All right, so it's not going to be perfect, but that's a hard one to draw. So we will call this an octagonal prism. And even if your picture is not perfect, what we can find is that we can figure out how many faces, edges, and vertices it has just by following the pattern. Remember, our faces are the 2 bases, right? And then you've got a rectangular face connected with each side. So two bases, and then they're eight-sided shapes. So it's going to have 2 plus 8, 8 faces. Now, let's look at our vertices, right? Well, let's look at our edges first, right? So our edges, and I might not have all the correct blue drawn there, so that's going to be kind of hard. But remember, we know from our edges that we've got 8 on the one base, 8 on the other base, that's 16, and then a third set of 8 connecting them. So that's going to be 24 edges. That's the pattern. And then vertices might be a little bit easier. 1, 2, 3, 4, 5, 6, 7, 8. Then on the back side, 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 and 8, so that's going to be 16 vertices. So how could I change that? So my triangular prism fits group 1 because we already have that shape, right? I kept the same shape, I just rotated it, right? So I didn't necessarily call it a different shape, I just rotated shape. So I'm going to kind of change this, and I'll say I wanted to show you a different shape, so I rotated the shape. But I did draw a new shape for octagonal prism, and how could I fit that? Well, what I want to do here is instead of 7 or 8 faces, what I might do is I might change my descriptions to say 7 or more, 15 or more, or 12 or more. So if I just change my description, instead of being exact, if I just say the lowest number and then more, then I'll be good. So those are just a few answers here. So I will just say answers may vary because you might have chosen different ways to describe the shapes in group 1. Shapes in group 2, you might have chosen different shapes to add, and that's fine. For problem number 2, we are completing a table here. So first, let's name each shape. Okay, so this shape is an oval. And so it's not a shape we use an awful lot, but most of us know the name of that shape. This is a trapezoid, but I'm going to get specific. This is actually an isosceles trapezoid. It's a type of trapezoid. Trapezoids are four-sided shapes. They're quadrilaterals that have only one pair of parallel sides. So that's going to be my top and my bottom, my two bases. But the two slanted sides are the exact same length. So that is what it means to be an isosceles trapezoid. My third shape has got 6 sides, 1, 2, 3, 4, 5, 6. So this is a hexagon. It's actually a regular hexagon because all 6 sides are the exact same length. And it's the most normal hexagon we see. There are a few different types of trapezoids. And then this is a triangle. We could call it a triangle. This is actually, it looks like an equilateral triangle. But if you just put triangle, that's fine. It's a type of triangle that has all sides and all angles the exact same. So, is it a polygon? Well, this polygon means it's closed and straight. So my oval is closed, but it's not straight, so no check mark. Isosceles triangle, or isosceles trapezoid, is closed and straight. So is my hexagon, so is my equilateral triangle. Does it have vertices or corners? No for my oval, and then yes for each of these three. Is it a quadrilateral? So this means corners, and this is 4 sides. No for my oval, which means my oval gets no shape. It gets no check marks at all. But I do have a 4-sided shape here, and no for hexagon and no for equilateral triangle. All right, so add another column and add a different shape. Look what it needs to have. Check marks in the bottom 3 rows. All right, so I need a new shape that is a polygon, has vertices, and is a quadrilateral. So I've already done a trapezoid. How about I just do a square? So that would work. A square would work because it's got four sides, it's closed and has straight edges, and it has corners or vertices. So your final column answer may vary, or your final column shape may vary. You could have put a rectangle, you could have put a rhombus, you could have put a parallelogram, you could have put a kite. There are several things you could have put. All right, for our third, we have some shapes. We need to name each shape, find the ones that are prisms. We need to find why 2, 7, and 12 are different from the other shapes, so on and so forth. All right, so let's just name each of these. So this is not really a geometric shape, but I'll just call it a spiral. And our next one is definitely a geometric shape. That's a cube. This has got 8 sides, so we'll call this one an octagon. Now this is a trapezoid, but it's not an isosceles trapezoid. It's a right trapezoid. So a right trapezoid is a trapezoid that has right angles. So it's got square corners, but it only has one pair of parallel lines, and it is a quadrilateral. So it is a trapezoid. So this is a circle. This is a four-sided shape, and it is a rhombus because it has 4 equal side lengths. So we've seen this before. This is a triangular prism. This is not a geometric shape, but it's a heart. This is a square. All right, so we have 1, 2, 3, 4, 5 sides. This is a pentagon. This is a triangle, and all the side lengths are different. So it's technically a scalene triangle. We can classify them by their side lengths. And then this is a cone. So that is a three-dimensional shape as well. All right, so name each shape. We've already done that. Which shapes are prisms? Okay, so definitely 7, a triangular prism, but we also have a cube. Remember, a cube is a prism. So I'm just going to put 2 and 7. It is a prism, though the name prism is not included. The word prism is not included in the name. Which shapes are quadrilaterals? Those are four-sided shapes. So I see a right trapezoid, 4. I see a rhombus, 6. And I see a square, 9. Those are my four-sided shapes. What other quadrilaterals could be included in this table? All right, so I've got a trapezoid, I've got a rhombus, I've got a square. I could add a rectangle. I could add a parallelogram. One you don't really get into, but a kite, literally one that's a kite shape. That's actually a technical geometric term. Which shapes are not polygons and why? Okay, so we've got two classifications of not polygons. So 1, 5, and 8 are not polygons because they are not closed and straight. So a polygon has to be closed and straight. And the heart, the circle, and the spiral are not closed and straight. But also, I've got a cube, rectangular prism, and cone because they're 3D. Polygons need to be two-dimensional. And then how are 2, 7, and 12 different from the other shapes? They are 3D. So we basically have already answered that. So those are your answers for that one. If you are interested in looking for the readiness practice for 3.6a for either the intermediate or the proficient versions, or for the readiness practice line with any other standard, you can find them by using the link in the video description.